Hello, guys. So today we are to our mini lesson. You know what that means? That means we have a quiz today, and if you're wondering when today is, hopefully you're not. That would be Thursday, November 5th. But as for day 5, today we're going to be talking about another example of a transformation, our third. And if you're wondering, well, frick, how many of these are there? There are 4 transformations. So if you're wondering how many, there's going to be 4 total. This one is going to be rotations. So this is one that can be a little bit confusing for me. I'm not much of a visual learner. So for me, this is the one that gives me the most trouble, if I'm being honest. I always want to be honest with you guys. So what are we going to be doing? Determine the effect of rotations and how they affect, coordinate plane. We're back to talking a little bit more about the coordinate plane and how we rotate around it. And then understanding what it means to be congruent, which we know is kind of like equal. We know that's quote-unquote equal, and how it relates to the transformation that is a rigid motion. So in other words, as I mentioned before, same size, same shape. Same size, same shape. When we talk rigid motion, we talk equal. Whatever new figure we get, it's still the same size, it's still the same shape. So real quick, what is a rotation? Well, it's a spinning motion, which some of you guys probably pieced together, where you turn a figure about a point or a line. So when we spin around an axis, so let's say we have this right here, it would be like if I took this and rotated it around, you can tell I'm really good at this, the boom, or boom. And when we rotate this way, this is clockwise. That is clockwise. When we rotate this way, that is counterclockwise. Think about the hands on a clock as they go around. Okay? And so we know we can turn it clockwise or counterclockwise, like I just said, based off number of degrees. Generally, this is going to be 90, 180, 270, or 360. In general, that's usually what we're going to see. And we get to cheat a little bit here, guys. Check it out. So whenever the rotation is around the origin, and I can't stress that enough, when it is the center of rotation is at the origin, 0, 0, we can see some patterns here. Check out these relationships. I want to draw your attention to 90 degrees clockwise and 270 degrees counterclockwise. I want to draw y'all's attention to these. So check it out. So the point of the preimage before the reflection, x, y, x, y. Check out what happens. So when you rotate something 90 degrees clockwise, so we go boom, 90 degrees clockwise. Check out what happens. The x becomes y. Whatever the y value was, that's now the x value. And whatever the y value was is now the negative version of the x value. You're thinking, oh gosh, there's 6 of these. How am I supposed to remember? Well, number 1, you're going to have this chart. And number 2, check it out. These are the exact same. And I'm sure some of you guys know why. Because if we rotate 90 degrees clockwise, and then we rotate 270 degrees counterclockwise, it's the same thing. This brings us to the same point. And guess what? The same thing happens for if you rotate 90 degrees counterclockwise and 270 clockwise. Same thing is going to happen here. These two are going to be connected. You can see that right here. So that's pretty convenient. And we see with rotation of 90 degrees counterclockwise, the x becomes negative y. So the x takes on, it's still x, but now it has the value of whatever y was but negative. And then the y value takes on whatever the x value initially was, because you're rotating towards the x-axis there. I'm sorry, towards the x-axis there. And then finally, we just have kind of one that's its own unique thing here. I'll highlight it in yellow. Rotation of 180 degrees. Obviously, it doesn't matter which way you rotate. You go 180 this way, you're there. You go 180 this way, you're there. It's the same thing. We see that all that happens is x and y change signs. They're in the same positions, just now they're either both below or both above. Or if they're on the sides, they're over on the other side. And then, of course, 360, you are back to where you started. That's kind of nice. If you rotate 360, check it out. It's the same thing. You rotate all the way around and you're back to where you started. So let me show you guys the best way to probably do this here, in my opinion. So check this out. We got looks like a five-sided shape here. You may call that a pentagon. We want to rotate 90 degrees, and here's the key, counterclockwise. 90 degrees counterclockwise. So big thing. First thing I would do is see what my points are. So here's the original. P, 3, -2. Q, 5, -2. R, 6, -4. S, 4, -5. And T, 2, -4. That's the original. As for the new points, when we rotate, here's our 90 degrees counterclockwise turn. So we're going to have P. So if we're going 90 degrees counterclockwise, we know X is going to become -Y. So our X was originally 3, so it looks like it's now going to become -Y. So here was Y. Well, it was negative, so now that's positive. And the Y is going to become whatever X was. So X was 3, now our Y is 3. Let's do another one here. Let me zoom out a little bit. It's counterclockwise. Let's try again. Q. Should have given myself a little bit more room. That's okay. There we go. So we know our X is going to be -Y. So I look and I say, what was Q's Y? Okay, it was -2. So change the sign. That's now a +2. And our Y value is going to be whatever X was. So X was 5, so 2, 5. Okay? Then we go R, and I know this is a little confusing, guys, but stick with me. X is going to be whatever the opposite sign of Y was. So R's Y was -4. That means our X is going to be +4. And then our Y value is going to be whatever the X of R was. So that is 6. You guys are probably starting to catch on now. S, X is going to be whatever the opposite of Y was. Y was -5, so our X is going to be +5. And then our Y is going to be whatever X was, which is 4. And then finally T, X is going to be the opposite of whatever Y was, so 4. And then our Y is going to be whatever X was, which is 2. I know it's a little bit of a long process, guys, but the tough part is over. Now all you got to do, here's our new points. Make sure you put those tick marks there so we recognize it. All you got to do now is graph it. So 2, 3. There's P. 2, 5. There's Q. 4, 6. There's R. 5, 4. There's S. And 4, 2. There's T. Check it out. We've rotated this thing 90 degrees counterclockwise. Boom. Going left to right around the origin. So what I'm going to let you guys do, I'm going to let you guys try. We're going to rotate 270 clockwise. So 270 clockwise, wait a minute. 270 clockwise and 90 degrees counterclockwise. It's the exact same thing here. Negative y and x, negative y and x. So I'm going to let you guys try number 2. It's going to be kind of the same thing here. Same exact transition. So go ahead, guys, give me your best shot on number 2. You can pause the video. Let's see how you guys did with these points. So I labeled out my points, W, X, Y, and Z. Since we're going clockwise, I thought I'd label my points clockwise. So then, 270. The easiest way to do this is maybe just don't look at the X's and just look and say, okay, I know all my Y values are just going to be the X's. So 4, 4, 2, 2. Okay, 4, 4, 2, 2. Well then, all my X's down here are just going to be my Y's, but the opposite sign. So negative 4, negative 1, negative 1, negative 3. And now let's graph it. Here's the easy part. There's W, X, Y, and Z. It's really just formulaic. That's all there is to it, guys. I know it's a little tricky, but remember, you will have this when you take your test. All right, last page. Again, this is our mini lesson. And this is the only part, along with kind of that table, that might intimidate some people, if you're anything like me. But it's just because some of us maybe don't know how rotations work whenever we have different shapes. So, for example, if you need to know, if you see this is divided up into pieces, how many pieces does a hexagon have? That's right, it's got 6 sides. So what we do is we say, okay, there is 360 degrees in the whole thing. 360 inside the whole thing here. Well, if you want to figure out what that is per piece around the origin, you can divide this by 6, the 6 sides. And you find out that, oh, there's 60 degrees in each piece. So check it out. That's 60 degrees. That's 60 degrees. 60, 60, 60, and 60. Okay? And so once you figure that out, this is a cakewalk. Check it out. 120 degrees rotation of F about 0. So the question is going to be, what point or segment by rotating is this going to bring us to? So if we start at F and we go 120 degrees, and we're going counterclockwise. That's important right there. We're going counterclockwise. So then from F, we're going this way. So we go 60, 120. Boom, boom. That brings us right to this right here, which is, we go from there to there. That is point D. Try this one, 180 degrees of B. So we start at B and we rotate 60, 120, 180. Yep, we jumped all the way to the other side. That's point E. How about 300 degrees rotation of BG about 0? So here's BG. So what line segment are we going to rotate to? Let's see, 300 degrees. 60, 120, 180, 240, boom. That takes you all the way to BC. Line segment BC. Did you guys see that? 60, 120, 180, 240, 300. And then finally, 240 degrees of FE about 0. Here is FE. And so 240 would be 60, 120, 180, 240. That'd be BG. Hopefully you guys are feeling pretty good on that, because we've really only got two things left, and one of it's a throwback. So check it out, guys. I'm going to let you guys try this one. The big thing is, though, before you try it, let's see how many sides we're dealing with. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, we got 10 sides. Okay. Now it is a regular decagon. It means it's got 10 sides. And if it's regular, that means it's got 360 degrees. So you divide that by 10. We end up finding out that each component is going to be made up of 36 degrees. So imagine this is like a big old wheel that we're turning. It looks like we're turning it, big thing here, turning it clockwise. So we're going like that. Clockwise is like this. And so I'm going to let you guys see what you think about 1, 2, and 3. Give me your best shot on these 3 right here. Check out what I did, guys. I kind of split this into like a pizza. So I put it into 10 slices of 36. So if we're going to go from D to A, I said, okay, 36, 36, 36, 36, 36, 36, and 36. That is 1, 2, 3, 4, 5, 6, 7 36s. So 36 times 7. Oh, remember we're going clockwise. That'd be 252 degrees. How about what is the angle of rotation that maps B to H? Okay, so we're going B all the way around to H. Looks like that is 1, 2, 3, 4, 5, 6 slices. So 36 times 6. Going to give me 216 degrees to get from there to there. Just like I went from there to there. And then last one, what about the angle of rotation that maps FG to DE? Oh man, we're going to be going all the way around to there. So from FG all the way around. Well, that looks like 1, 2, 3, 4, 5, 6, 7, 8. So that would be 36 times 8, which is going to give us 288 degrees. How about another way you could have done that? Could we have also just done 360 degrees, right, the whole thing, minus, how far away is FG to DE? Looks like 36, 36. Oh, I guess we could have just subtracted the 72 degrees that separates there to there and gotten the same thing, if you wanted a little cheat there. So last thing today, guys, this is a throwback to day 1. Little day 1 throwback here. And these can be kind of tricky if you didn't really lock in on them. So big thing, guys. X is a random variable that can happen. So for example, the event that 0 happens, the event that 1 happens, event that 2, event that 3. These are events. These are the probability that each event happens. These are all connected here. Now remember, what does probability have to add up to be? This plus this plus this plus this all has to add up to be 100% or 1. So the big important thing here first is, we need to figure out what the heck Q is. So we need to treat this like one big equation. We know that it's going to be 6Q plus 4Q plus 8Q plus 7Q. That's all got to add up to be 100% or 1. So when we add all these up together, 6 plus 4 is 10, 10 plus 8 is 18, 18 plus 7, that's 25Q equals 1. Divide by 25. Turns out Q is going to be equal to 1 over 25. And not only do we need to find Q, we need to use this value to find the probabilities of the table. So we're going to take this and we're going to plug it in. So 1 over 25, it's going to be 6 times 1 over 25, 4 times 1 over 25, 8 times 1 over 25, and 7 times 1 over 25. And when you do that, let's see what we end up getting for our probabilities here. I'm going to give you guys a second. The probability of getting 0, probability of getting 1, probability of getting 2, and the probability of getting 3. Let's see if we can get these as decimals, guys. I think decimals will be a little bit easier to work with than whatever ungodly fraction we have. So take a second. Let's see what you get. So we got the probability of getting 0 is about 24%. Probability of getting 1 is 16%. Probability of getting 2 is 32%. The probability of getting 3 is 28%. I know what some of you guys are probably thinking. You're probably thinking, Lord have mercy. Look at all this work, and this is just the first problem. Well, guess what? You just did the heavy lifting. This is the heavy lifting right here. Once you've done this, the rest of this is easy. The rest of this is easy, guys. Check it out. Number 2, what's the probability of us getting an event occurring that is 2 or less? So the chances of getting 2, 1, or 0. Oh, well, that's just going to be this probability, that probability, and that probability, which we know is 0.32 plus 0.16 plus 0.24. Yeah, you just add those up. You end up getting that probability is about, actually exactly, 72%. That's all there is to it, guys. The chances of our events being 2, 1, or 0. Try number 3 for me. See if you guys can do number 3. What's the chances of us getting an event that is bigger than 1, so not 0, not 1, so an event bigger than 1, and equal to or smaller than 3. So in other words, is what this is saying here. See what you guys can do. Let's see if you guys did it. So the chances of getting pretty much 2 or 3 to happen. So then 0.32 plus 0.28, we got about a 60% chance of event 2 or event 3 happening. So great job, guys. Don't forget, quiz today. And hopefully I'll be talking to you guys very soon. Thanks.